Good day, everyone, and welcome to where we are putting together solutions to those problems students are getting in the areas of math and science. This video specifically deals with CSEC Mathematics and the topic of matrices. We will be looking at the past paper questions from May 2009 until 2013. Feel free to like the video and add any comments down below so we can create more videos to help you in any areas of math or science at both the CSEC or CAPE levels that you are getting problems with. Don't forget to look at the description down below, in which we gave the suggestions of the order of videos to look at to cover the entire math syllabus. Let's recap the major topics in CSEC Math, and this video deals with the topic number 9, vectors and matrices. Topic number 9 comes for 4 questions in the multiple choice, paper 1, and the last question in paper 2 with 12 marks. So this gives us a total of 16 compulsory marks. We are specifically dealing with matrices, and in 2009, that was one entire question all by itself with 15 marks. However, from 2010 until 13, the format of the exam changed, and the vectors and matrices were combined together for the last question. So the matrices questions that came from 2010 to 2013 was worth half of the 15 marks. May 2009, number 14. A. The value of the determinant of M, that matrix, which is x4, 3x, is 13. Calculate the values of x. So let's recall. If we have any matrix, let's call it A, with the items A, B, C, D, the determinant of A, det, or it can be written A with these two straight lines on the side, the modular signs, that number is A times D, the numbers we have in red, when we multiply them, minus the numbers we have in green, BC. So let's apply that rule for here. So M is equal to x4, 3x, as was given above. So the modulus of M, or the determinant of M, is equal to multiply the red terms, x by x, minus multiply the green terms, 3 by 4. And we know the determinant of M, that's 13, so let's substitute that. 13 is equal to x squared minus 12. And if we want to find x squared, we need to move the 12 from the right-hand side and carry it across to the left. The 12 is subtracting. When I carry it across, it will add. So what will that give us? 13 plus 12 is equal to x squared. 25 is equal to x squared. So what is x? The square root of 25. And what's the square root of 25? Plus 5 and minus 5. So those are the two values of x. Let's look at part B now. The transformation R is represented by the matrix minus 1, 0, 0, 1. The transformation S is represented by the matrix 0, 1, minus 1, 0. Write a single matrix in the form of ABCD to represent the combined transformation S followed by R. So let's recall how we multiply two matrices, two 2 by 2 matrices. So if there's ABCD and EFGH, I've put them in colors so we can see that when we're multiplying, in the first matrix, the first row is multiplied by the first column in the second matrix. So we'll see the first row I have in black and the first column I have in red. So it'll be AE, A times E, plus B times G. And then we take the first row in the first matrix and multiply by the second column. So it'll be those that are in black times what is in green. A times F plus B times H. And then we continue with what is the second row in the first matrix times the first column. So what's blue times what is red. And that'll be C times E plus D times G. And finally, C times F, blue times green again, plus D times H will give us our last item. So let's apply that to our multiplication. Now they're telling us that we applying S first and then R. So S will go on the right because that is what will be applied first, and then R. So RS is equal to minus 1001, which is the R term, times the S term, 0, 1, minus 1, 0. Right. And if we do the same application of the formula above, we will end up with minus 1 times 0 and 0 plus 0 times minus 1. Right? The black terms by the red terms, and then the black terms by the green terms, and then the blue terms by the red terms, second column by the first row, and then the second column by the second row by the second column, blue times green. Right. So we've used these colors in order for students who are getting problems in this topic to follow exactly which numbers are multiplying by which. And if we simplify, minus 1 times 0 is 0, plus 0 times minus 1, that's 0. And then the second one, minus 1 by 1 is minus 1, plus 0 zeros are 0. And then 0 zeros are 0, plus 1 by 1 is minus 1. And the final one is 0 and 0. And if we simplify, we'll get 0, minus 1, minus 1, 0. Now, if we were to apply that, I've made a little sketch here on the side to give you an idea what's happening. Right, with the first term, it's telling us to rotate 270 degrees. That's what S is doing, to move 270 degrees in a counterclockwise direction. It's the same as rotating 90 degrees in the clockwise. I'm just moving counterclockwise for all. So S is telling, if we put a value, our little point here on our graph, and we rotate that, it will rotate 270 degrees in an anti-clockwise direction. And then R is telling us to rotate again, to reflect along the y-axis. So it does the rotation and then it does the reflection. And that is what the combination RS is. Now let's look at part 2 now. Calculate the image of the point 5 minus 2 under this combined answer that we got in the first part, under RS. So the image of this point that we're going to find, if we have IM is equal to RS times 5 minus 2, and we've just looked at it in the sketch because where we have that point, x to the is 5 and you come down 2 places, so it's kind of generally there, right? So we say 0 minus 1 0 by 5 minus 2. The top row by the column, 0 times 5 plus minus 1 times minus 2. And then the second row by the column, minus 1 times 5 plus 0 times minus 2. And we can simplify, 0 by 5 is 0, and minus 1 by minus 2 is plus 2, and minus 1 by 5 is minus 5, and 0 by minus 2 is 0. And finally, so what is the image of our point? It will be 2 minus 5. And we can see that clearly from our sketch. In part C, the matrix N is equal to 3 minus 1, 2, 5. And part 1 of that, they're asking us to determine the inverse of this matrix. So let's look at the steps for it. The first step will be to find the determinant of that matrix. And we went through this just now, which was that if the matrix A is ABCD, then it will be AD, the red terms, minus the green terms, minus BC. So let's apply it here. So matrix N is 3 minus 1, 2, 5. So the determinant of N, or mod N, is 3 by 5 minus 1 by 2. The red terms minus the green terms. And let's simplify. 3 5s are 15. 1 by 2 is 2. And we have 2 negative signs, so that will give us plus 2. And 15 plus 2 is 17. So the determinant is 17. What's the second step when we're finding the inverse? Find the adjoint of the matrix. So let's recall that if we have a matrix A, B, C, D again, and we want to find the adjoint, what we do is we switch the red terms. A and D switch places, and the green terms become negative. So instead of A, B, C, D, the adjoint will be D minus B minus C, A. So we will apply it here. If matrix N is 3 minus 1, 2, 5, the adjoint N is 5, and we change the sign with the minus 1, it becomes plus 1. We don't need to write the plus. The 2 becomes negative 2, and remember the 5 switch with the 3. So that's the adjoint. And the final step to find the inverse of the matrix, to find A inverse will be 1 over the determinant, whatever number we got, times the adjoint A, the adjoint of the matrix. So let's apply that to our question here. Matrix N inverse means the inverse of N is equal to 1 over the determinant, 1 over mod N, times the adjoint N, which is 1 over 17 times 5, 1 minus 2, 3. Just bringing it down from above. And we don't even need to write the multiplication sign. Right, part 2, to finish this question. Hence, calculate the value of x and the value of y for which those simultaneous equations are. 3x minus y is equal to 5, 2x plus 5y is equal to 9. So let's recall, if we want to solve simultaneous equations, what's the first step? Let's try and rewrite it in the form ax equal to b, so, as where a, x, and b are matrices. So how do we do that? We pull out the coefficients, which are the numbers in front of the letters. So what's the number in front of the x? 3, and minus 1 in front of the y, and 2 and plus 5 by xy is equal to 5, 9. So it looks like the form there, nx equal to b. Now, what does second step tell us to do? Let us pre-multiply by A inverse on both sides. So we have A inverse A, x is equal to A inverse b. Let's see if we do the same thing here. So we have n inverse n, x by n inverse b. Part 3 now, simplify. Now, why did we do that? N inverse times n, when we have two matrices and they're multiplying by each other and one is the opposite of it, they will cancel off, meaning we'll be left with I, the identity matrix. So we'll have Ix is equal to, and let's substitute, we know n inverse, we got that just now in part 1. 1 on 17 by 5, 1 minus 2, 3. And what is b? b is 5, 9. So Ix is the same as writing x is equal to 1 over 17, and let's just solve this multiplication. 5 by 5 is 5 by 5 plus 1 by 9 minus 2 by 5 plus 3 by 9. And we can simplify. X is equal to 1 over 17 by 5 5 is 25 plus 1 9 is 9 and minus 2 by 5 is minus 10 plus 3 9s are 27. And we can simplify further. X is equal to 1 over 17 by 25 plus 9 is 34 minus 10 plus 27 is equal to 17. So, and if we multiply by 1 over 17 to each term, 17 into 17, 1, 17 into 34, 2, and 1 over 17, 17's cancel, you're left with 1. And what was big X? The big X was really the X and Y values. So we've actually solved the question. They asked us to calculate the values of X and Y, and we got X is equal to 2 and Y is equal to 1. Now, we've solved it, but let's just double check that this is correct. If we substitute x as 2 into the top equation, we get 3 2s are 6 minus, what is y? 1. 6 take away 1, it works out. It gives us 5. And let's try the second equation. It must work in both equations. 2 2s are 4 plus 5 1s are 5. 4 and 5, it works as well. So we must check that both equations works, and that means we got our answer perfectly correct. We got our full 4 marks. May 2010, number 11, part A. A and B are two 2 by 2 matrices such that A, the first matrix, is 1, 2, 2, 5, and B is 5, minus 2, minus 2, 1. Part 1, find AB. So let's recall, as we did before, that AB is, I'm writing it here as a general formula in terms of black and blue rows in the first one, and columns red and green. And the reason being that when we're multiplying, we multiply the first row, the black row, by the red column, and then we multiply the black row by the green column. And similarly, we then do for the blue row by the red column, and then the blue row by the green column. And we can see it there. So let's apply this. So AB, we know the value, so let's go 1, 2, 2, 5 by 5 minus 2, 1. So if we multiply the black rows by the red column to give us the first item, it will be 1 by 5 plus 2 by minus 2. And similarly, let's continue. the black row by the green column will be 1 by minus 2 plus 2 by 1. And then the blue row by the red column, so it'll be 2 by 5 plus 5 by minus 2. And then the blue row by the green column, it'll be 2 by minus 2 plus 5 by 1. And then remember, this is the format for multiplying 2 by 2 matrices. And let's solve. 1 by 5 is 5. And 2 by minus 2 is minus 4. So we get 5 minus 4 for the first position. And then 1 by minus 2 is minus 2. And plus 2 ones are 2. And then 2 5s are 10. Plus 5 by minus 2 is minus 10. And 2 by minus 2 is minus 4. Plus 5 by 1 is 5. And if we simplify, 5 minus 4 is 1. Minus 2 plus 2 is 0. 10 minus 10 is 0. And minus 4 plus 5 is 1. So AB is equal to 1, 0, 0, 1, which is the identity matrix. Now, that's important to note. So let's go look at part 2. Determine B inverse, which means the inverse of B. So we just found out that AB is equal to I, the identity matrix. So if I multiply on the right side by both terms by B inverse, look what happens. Remember, it's important to get the correct order when we multiply matrices. So if we look at the left-hand side, we'll get A times B inverse. And B by B inverses, they cancel each other, they give us I. So AI is equal to I by B inverse. And when matrices are multiplying by the identity by I, then it's like multiplying by 1. It remains the same. So we're left with A is equal to B inverse. And that's what they wanted us to find. They wanted us to find the inverse of B. And the inverse of B is A, which is 1, 2, 2, 5. May 2010, number 11, part 3. Given that 5 minus 2 minus 2, 1 by xy is equal to 2, 3, write xy as the product of two matrices. So those are simultaneous equations in a different format. So let's see if we can follow the steps on the side, write it in that form, pre-multiply if we have to, simplify and solve. So 5 minus 2 minus 2, 1 by xy is equal to 2, 3. That's what was given above. And that first 2 by 2 matrix, that is the matrix B from before. And we call x and y the unknown, so we call it a matrix X, is equal to 2, 3. So if I want to get rid of B from the left-hand side, what I need to do, unlike normal multiplication where we carry it across by dividing, what we do is we multiply by its inverse. So B inverse times B times X is equal to B inverse. So I'm pre-multiplying by B inverse on both sides. And what does that give us? The B inverse and the B will give us the identity, I times X is equal to, and what is B inverse? B inverse we found in part 2 to be A. So we can substitute. Remember, I times X is really just X. And that will give us 1, 2, 2, 5, which is matrix A by 2, 3. And that's all we wanted to do at this point. It was to write XY as the product of two matrices. So in part 4, hence, if you reach this point, calculate the values of X and Y. So X, or XY, sorry, is equal to 1, 2, 2, 5 by 2, 3. And it's the same format. I've put the first matrix with red rows and blue rows multiplying by the column. So the red row by the column will give us 1 by 2 plus 2 by 3. And the blue row by the column will be 2 by 2 plus 5 by 3. And we can simplify. 1 2 is 2 plus 2 3s are 6. 2 2s are 4 plus 5 3s are 15. And finally, xy is equal to 2 and 6 is 8. 4 and 15 is 19. May 2011, number 11, part A. Determine the inverse of the matrix 3, 5, 2, 4. So let's remember the steps for inverse. First, find the determinant. And we recall that if the matrix is ABCD, then we multiply the red diagonal minus, which is the major diagonal, minus the minor diagonal, BC. Or the red values by minus the green values. So let's do that. So let us name that matrix. Let's call it P. So P is 3, 5, 2, 4. And I've used the same color so we can easily identify it. So the determinant of P, or mod P, which mod short for the word modulus, which are the straight lines around P, would be 3 by 4 minus 5 by 2, which is 12 minus 10, and we can solve, and that will give us 2. So we found the determinant of P. Now what's step 2? Find the adjoint of the matrix. So let's recall that the matrix ABCD, if we want to find the adjoint, what we do is we switch the terms in the major diagonal. So D comes up on top and A goes below. And we change the signs in the minor diagonal, in the green items. So it becomes minus B and minus C. So let's apply that. Matrix P is 3, 5, 2, 4. Let's switch the red terms. So we get the 4 on top and the 3 below. And the green terms, they change their signs. So it becomes minus 5 and minus 2. So last step to find the inverse. Now that we have gotten the determinant and the adjoint, it's just a substitute. A inverse will be 1 on the determinant times the adjoint matrix. So the matrix P inverse, which is what we want to find, the inverse of this matrix, will be 1 on the determinant, 1 on mod P times the adjoint P. And if we substitute, we know determinant is 2, so that's 1 over 2, brackets, adjoint is 4 minus 5 minus 2, 3. And we can stop here, or if you want, you can go on and multiply half by each term, which will give us 2 minus 5 on 2 minus 1 and 3 on 2. Part B now. The transformation M is equal to 0, A, B, 0. Maps the point R and T onto R prime and T prime, such that R, which was 7, 2, right? And we'll have that in our little sketch here. We'll make a sketch to see what's going on. It's at 7, 2 and is ending up at 2 minus 7. And T is at minus 4. That's why we're using a little green X for that one. Part 1. Determine the values of A and B. So we know M, the transformation, when it's applied to R, M times R will give us our new value, our new image, R prime. So let's substitute. 0A, B 0 by 7, 2 is equal to 2 minus 7. And the red row by the column, and then the green row by the column as usual. 0 times 7 plus A times 2, and B times 7 plus 0 times 2 is equal to 2 minus 7. Right? And let's solve. 0 times 7 is 0 plus 2A. B times 7 is 7B plus 0 is equal to 2 minus 7. And we simplify again. 2A is equal to 2 and 7B is equal to minus 7. Now you can go and work this out one side, but I think we can work this out easily here. If 2A is equal to 2, what is A equal to? A is equal to 2 over 2, which is 1. And if 7B is equal to minus 7, what is B? B is minus 7 over 7, which is minus 1. So we got A and B as 1 and minus 1. You could have not used R, but you could have used T. So MT equal to T prime, and you'd have worked it out and still gotten the same exact solution for A and B. So now part 2. Describe fully the transformation M. So M is 0, we know A, 1, we know B, minus 1, and 0. And if we recognize that, that would be like cos of 270 minus sine 270, sine 270, cos 270. So M is really telling us the transformation is a counterclockwise rotation of 270 degrees. And we can see that from the sketch. Or we can say it's a clockwise rotation of 90 degrees. Either one still ends up in the same area. May 2012, number 11. B. Calculate the values of A and B such that A 4, 1B 2 by 2 minus 4, 1 minus 3 is equal to 2, 0, 0, 2. So we have all the terms except A and B. So we can do our multiplication of two 2 by 2 matrices. And let's recall, if we have A, B, C, D and E, F, G, H, I've put them in colors, black and blue rows by the columns, because the first matrix, the rows are multiplied by the columns of the second matrix. So it will be black, which is the first row, by the first column, that's black by red, and then black by green, the first row by the second column, and then blue by red, the second row by the first column, and then blue by green, the second row by the second column. So we'll apply that here for AB. So it'll be A by 2 plus minus 4 by 1, and then A by minus 4 plus minus 4 by minus 3. And below now, 1 by 2 plus b by 1. And then 1 by minus 4 plus b by minus 3. And that will give us 2002. So if we simplify there, a by 2 is 2a, minus 4 by 1 is minus 4. And then we have minus 4 by a is minus 4a, and minus 4 by minus 3 is plus 12. And 1 by 2 is 2, and 1 by b is b, 2 plus b. And then 1 by minus 4 is minus 4, and minus 3b. And that will be equal to 2002. Now we can take any two terms here and solve for a and b. Right? I'm just choosing the first one, 2a plus 4 is equal, 2a minus 4 is equal to 2. You could have used the second one, minus 4a plus 12. Either one is still going to get the same answer. So you could try it afterwards. So 2a minus 4 is equal to 2. I want to find a, so I carry the minus 4, which is on the left side, and it's taking away or subtracting. So when I carry it across, it will do the inverse of subtracting, which is adding. So we have 2a is equal to 2 plus 4. 2a is equal to 6. So what is a? A is 6 over 2, because the 2 is multiplying on the left. When I carry it across, it will be multiplicative inverse, which is to divide. So 2 into 6 is 3. So we've solved for a. And I'm using 2 plus b, the third term. 2 plus b is equal to 0. So b is equal to, carry the plus 2 across, it will become minus 2. So we solve for a and b. You could have used the other two terms, and still solve for a and b. That's fine. Multiple ways to solve. And there's no reason to do it twice. Part 2. Hence or otherwise, write down the inverse of 2 minus 4, 1 minus 3. So we know AB, and AB is equal to 2002. But if we extract a 2 from there, we're actually getting AB is equal to 2 times 1001, which is 2i. So AB is equal to 2i. How does that help us? We want to find the inverse of b. So let's multiply by b inverse on the right side for both of them, and let's see what happens. b inverse is equal to 2i b inverse. They're all multiplying. B times b inverse is equal to I, right, the identity matrix. And if you get in problems, picture that as being 1. So a times I is equal to 2i times b inverse. And a times I is just a. And 2 times I is just 2 times I times b inverse. I b inverse is b inverse, so 2 times b inverse. So a is equal to 2b inverse. If I want b inverse, the 2 is multiplying. When I carry it across, it will be half. It will be dividing. So we're left with half, and we can substitute for a, 3 minus 4, 1 minus 2. And we can leave the answer as is. There's no reason to extend the process. May 2012, number 11, part 3. Use the inverse of 2 minus 4, 1 minus 3. And if we recognize in part 2, that was the matrix B, and they're asking us to use the inverse of B, which is B inverse. And we found that just now. Use that to solve for x and y in the matrix equation. So we're solving for simultaneous equations here, right? 2 minus 4, 1 minus 3, xy is equal to 12, 7. And let's look at the steps to solve. We've done this multiple times already. First, write it in the form of matrices. A times x is equal to b. Then pre-multiply to get rid of pre-multiply a inverse on both sides. And when we simplify, a inverse by a will give us I, and the I times x will give us x. So it will simplify to x equal to a inverse b, and then solve by substituting the actual values. So let's follow those steps. We already have the first line, and now we know is b times x is equal to 12, 7. So if we want to get rid of the x, we want to get rid of the b, sorry, then we have to multiply by b inverse in front, by b, and on both sides. So we're left with b inverse by b is ix is equal to, and we know b inverse. We got that in part 2. A half by 3 minus 4, 1 minus 2 by 12, 7. And notice I put red rows and blue columns as usual, so you could follow the format. So ix is the same thing as x. Right? Multiply by the identity matrix, doesn't change the values. So it'll give us a half by red row by the column, so 3 by 12 plus minus 4 by 7, and then blue row by the column will be 1 by 12 plus minus 2 by 7, And we can simplify. X is equal to a half by 3 12s are 36, take away 4 7s are 28. And then 1 12 is 12 plus 2 7s are 14 minus 14. And we can continue. A half of 36 minus 28 is 8, and 12 minus 14 is minus 2. So a half of that will be 4 minus 1. And that will be the x and the y values. And if we had expanded this equation, we would have gotten the equation as 2x minus 4y is equal to 12. And 1x minus 3y is equal to 7. If we substituted the values of x and y in there, being 4 and 1, it would have worked out for both of them. So we know we've done the correct thing. May 2013, number 11b, given that M, this matrix, is 2, 1, 4, 3, part 1, evaluate M inverse, the inverse of M. So we have our steps for the inverse. The first step will be to find the determinant, mod M or det M. And let's recall that if we have any matrix A and they're given the values A, B, C, D, I notice I have them in red and green. Then to find the determinant, we're multiplying the red terms, which is along the major diagonal. So that's AD minus what the green terms, BC. So we're going to apply that to here. So since M is 2, 1, 4, 3, then the determinant is 2 by 3, the red terms minus the green terms, 1 by 4. Remember in the exam that there are no colors, that they're all black, but we're using colors here to help assist you, and so that you'll remember this. So let's simplify. 2 3s are 6, minus 1 4 is 4. 6 take away 4 is 2. So we finish the first step. Let's look at the second step now. Find the adjoint of the matrix. So the adjoint of the matrix is another matrix. It's just that the terms have shifted slightly. So if we have a matrix A, B, C, D, I still have them in red and green. Then to find the adjoint, what we're doing is we're switching the red terms, the ones on the major diagonal. So the D comes up on top and the A goes down below. And we're changing the sign on the green terms. So it becomes minus B and minus C. So let's do that here. So matrix M is 2, 1, 4, 3. So if we find the adjoint, then the 3 comes up on top, the red 3, it replaces the red 2, and the red 2 goes down below. And the green terms, we change sign, so it becomes minus 1 and minus 4. So part 3, find the inverse of the matrix. To find the inverse of the matrix, we're just going to say A inverse is 1 over mod A, or 1 over the determinant of A, times the adjoint A. So let's apply that here. Matrix M inverse is 1 over determinant of M times the adjoint M. By substituting, we'll find that 1 over 2, because the determinant was 2, by the adjoint of M, which is 3 minus 1 minus 4, 2. We can work it out if you want, or leave it as is, because they are nice whole numbers. Let's look at part 2. Show that M inverse is equal to I. So what they're asking us to do is take the left-hand side, the matrix M, and multiply it by M inverse, and see if we're going to get an identity matrix. So let's try that. Left-hand side, 2, 1, 4, 3, that's M, times, what is M inverse? A half by 3 minus 1 minus 4, 2. And we could pull out the half and put it in front. So we'll have 2, 1, 4, 3 by 3 minus 1 minus 4, 2. And notice I've put them in black and blue for the rows and red and green for the columns. We're trying to maintain that standard, so you get accustomed doing this. And let's recall when we're multiplying 2 by 2 matrices, 2 sets of them, A and B, we follow the same format as we explained before, which is the first row, which is the black terms multiplied by the red column, and then the black terms multiplied by the green column, and then do the same for the blue. So let's apply that and let's solve. So we're going to get a half by the black terms, 2 by 3 plus 1 by minus 4. So that's the black by the red, and then the black by the green, 2 by minus 1 plus 1 by 2, and then the blue by the red and the blue by the green. 4 by 3 plus 3 by minus 4, and then 4 by minus 1 plus 3 by 2. And let's simplify. So we keep the half as is, and 2 3s are 6, and 1 by minus 4 is minus 4. 6 minus 4, and then 2 by minus 1 is minus 2, plus 1 2 is 2. And then 4 3s are 12, plus 3 by minus 4 is minus 12. And 4 by minus 1 is minus 4, plus 3 2s are 6. And if we simplify, 2 3s are 6, minus 4, minus 2, plus 2. 4 3s are 12, 12, take away 12. And 4 by minus 1 is minus 4, plus 6. And we can simplify further, and we get a half by 6 take away 4 is 2. Minus 2 plus 2 is 0, 12 minus 12 is 0, and minus 4 plus 6 is 0. And if we multiply by a half throughout, we're going to get a half by that. It will give us 1001, which is the identity, which is the right-hand side. And when you've done a proof and you've shown it, you can do one of two things. And they are either write quod erat demonstrum, which is a Latin phrase, which basically means that they ask us to show the proof and we have proven it. Or if you want, instead of writing QED, you can just draw a small rectangle which indicates the same thing has been done, that you've shown the proof. May 2013, number 11. Use a matrix method to solve for R, S, T, and U for unknowns in the following equation. 2143 by RSTU is equal to 214 minus 1. Now, let's replace them. Now, understand that this is like solving simultaneous equations, so we're going to follow the same steps, which are to write it out into some format like matrices. A times X is equal to B, and then pre-multiply in order to get rid of the A on the left-hand side, and then X is equal to A inverse B, and substitute and solve. So we're going to do the same steps. So the first thing is to write the format. So the format is M times X is equal to B. And if we want to get rid of the M, then we have to multiply its inverse. M inverse times M, X is equal to M inverse times B. Remember, if we're putting the M inverse in front, we have to put it in front on both sides. And if we put it in the back, we have to put it in the back both sides. It's important where it lies. Multiplication by matrices is not commutative, meaning A times B is not equal to B times A in most cases. It's different to 3 times 4 is equal to 4 times 3. That shows commutativity. Now let's recall from what we did before that M inverse by M will give us 1001. We've just proven that. Times X is equal to a half, and let's substitute. A half by 3 minus 1 minus 4, 2. That was M inverse. We just got that. Times B, which is 214 minus 1. And when we're multiplying 1001, that is really I times X is equal to a half, and let's multiply rows by columns again. So 3 by 2 plus minus 1 by 4, and 3 by 1 plus minus 1 by minus 1, and then minus 4 by 2 plus 2 by 4, and minus 4 by 1 plus 2 by minus 1. And let's see if we could simplify. 3 2s are 6 minus 4, 3 1s are 3, minus 1 by minus 1 is plus 1, and minus 4 by 2 is minus 8, plus 2 4s are 8, and minus 4 by 1 is minus 4, plus 2 by minus 1 is minus 2. And that means that X, which is RSTU, is equal to a half times 6 take away 4 is 2, 3 plus 1 is 4, minus 8 plus 8 is equal to 0, and minus 4 minus 2 is minus 6. So a half of that will be 1, 2, 0, minus 3. This brings us to the end of this video on CSEC past paper questions in the topic of matrices. We've just completed the past paper questions from 2009 until 2013. Our next video will be from 2014 until 2018. So don't forget to look at the description down below, and it gives you the order in which we must look at our videos. That is best for us to get an increase in understanding of math and get a better grade when you're writing exams.